Good morning, class. We are going to do our constructions today. So I've created my own video for this. You can also watch these on YouTube as well. There are 4 constructions that we're going to do today. We may add one more on later. I'll have to just check on that, but we're just focused on these 4 that I have here on these slides here. All right, so the first one is construct an equilateral triangle. For those who don't know what an equilateral triangle, equa is the same as equal, and lateral means side. So equal sides. So all 3 sides are going to end up being congruent. This is our final picture down here from our constructions. As you can see down here, these are called hash marks. These little short segments on each side. Each one's called a hash mark. So when I have the same number of hash marks on a side, that means all those sides are congruent. Congruent means it's similar to equal. Equal deals with the number, okay, the length of it. Congruent means the actual shape itself is exactly the same, which obviously means it's going to also be equal in length. So congruent and equal are similar, but equal deals with a number, which that was 5 centimeters, whereas congruent deals with the actual shape itself. These two lengths of these 2 segments, or all 3 of these segments in this case, are all exactly the same length. Okay, so some more vocab that you need to memorize. All right, so how do we do it? You're going to be given a segment, such as this right here. It doesn't have to be like this. It could be at an angle. Okay, it doesn't matter. I just made it horizontal. Okay, you take your compass. Those got extra credit if they bought it over the weekend and brought it in first day of class. And you put your pointer, I call this the pointer, on one end of your segment. You open up your compass so that the pencil, I call this the pencil because it's got the pencil on this end, it is on the other end of your segment. And then you go ahead and draw yourself an arc like this that goes more than halfway. So this is about halfway, okay, in the segment. Draw it so it goes a little more than halfway. Now, if you watch some videos, I'll say draw an entire circle. You can do that, but you're not using any of this whole other part of the circle. So it's sort of a waste, and you might mess up doing the entire circle. So the key is you just have to go more than halfway on this arc, and that's what it says right here. Okay, and then part B, all you do is switch it. You put the pointer on this end, and the pencil over here on this end. So you shouldn't, since it's already open to that amount, you shouldn't have to move it at all. You just turn it around, put the pointer here, pencil here, draw your arc right up here. Again, a little more than halfway. Then you see that it intersects right there. Okay, so intersects right there. So the last thing you do is you take your ruler and just connect them to the endpoints of this segment right here. And now we have an equilateral triangle. It should be very simple. 2 steps. One arc here, turn it around, arc there, and then just connect them with the ruler with the intersection and the 2 endpoints. All right, so that's an equilateral triangle. Next one is an angle bisector. So they have to give you an angle. So I've given you this angle right here, for example. It doesn't matter how big the angle is or how small, you still do the same instructions. Okay, so as it says, put the pointer on the vertex. Remember, this is called the vertex, where the 2 endpoints of the 2 rays intersect right there. It's the vertex. So point C is the vertex. Stretch the compass an average distance. Okay, you don't want it really tiny, so it would be coming here. Much harder to deal with. Open it up, a little bit. It could be here, it could be here, it could be here, it could be here. Just some average distance. It's not real small. Okay, and then you get your pointer on the vertex, and then you just draw an arc so that it goes through both rays. Okay, go ahead and label those points. I just call them A and B. I use this as C, so I just pick 2 other letters, A and B. Okay, then as it says in step 2, I take my pointer and put it on one of these, either A or B. So on this one here, you see the last step here, you have the pointer on B, and as it says, open the compass more than halfway to B. Or could we start first when we started on A? So they had the compass or the pointer on A, open it more than halfway to B. If you want, you can go all the way to B. Some people just like to do that. Okay, but it has to be at least more than halfway. If you want to go all the way, it's all good. Draw yourself an arc. So that's this arc right here. And as it says, then put the pointer on B. Just switch it around, turn around, pointer on B, and whatever that distance was you had, that you had opened the compass up from A, you keep the exact same. So if you had it all the way to B, then it would be all the way to A when you turn it around. Otherwise, it's at least more than halfway. So all you do is turn your compass around, put the pointer here, draw your arc right here. So now again, you're going to get an intersection between those two arcs right there. That's it. It's called D because we've already used A, B, and C. Just call it D. Okay. And lastly, then is I'll explain these here in just a second. So technically, all you had to do is come up with this new point D here. We first came up with the A and B from the first arc. Then after open it more than halfway, doing two arcs from here and here, get point D. Then I just take my ruler and draw a ray from the vertex C through that point D. And then these two angles are equal, which means it bisected the big angle. So remember how we used hash marks on lengths of sides being congruent? We'll use arcs. These little arcs, that shows the angles are congruent. So since that has one arc and that has one arc, that means these two angles are congruent. I could have had two arcs and two arcs. The same number of arcs mean that those angles are congruent, just like the same number of segments means those segments are congruent. Okay, so now that's how you construct it. Okay, now over here, okay, going down here on this side here, I have this because one of these questions, one of these steps was on the PARCC test last year. So sometimes they just ask you, okay, what are the steps to make an angle bisector? And they'll give you the steps in random order, and you just put an order, A, B, C, on which order. So you'd pick, obviously, put the pointer on the vertex, draw an arc through the two rays. They might say draw a circle. Again, you could draw the full circle. It doesn't do any good, because you're not using any of this over here. The key is getting these two intersection points. And then put the pointer here, open it more than halfway. They might say put it on A, draw an arc, turn around. That'd be step 2, step 3, and then step 4, connect them, and there's your angle bisector. Okay, so that's the steps, but sometimes they'll ask certain steps on what is being established in each step. Okay, so step 1, when we drew this arc right here, and then we come with points A and B, obviously the pointer and this distance right here from here to here is exactly the same all the way. So that means the distance from C to A is congruent to the distance from C to B. That's why you saw, and that's why you see me put these hash marks on here showing segment CB is congruent to segment CA. So that's what you are showing right here. Again, if you didn't write the word segment, you could put the segment symbol above each one instead of saying the word segment in front. Okay, step 2. When we came up with this point D, what did we establish? Well, remember, this distance that we went to draw these two arcs was exactly the same. So when if I connect B to D and A to D, these two distances are now congruent. Okay, and notice I used 2 hash marks because I've already used 1 showing these two are congruent, so I go up to the next number, 2. You could have skipped and gone 3. Okay, there's not an order you have to go in, but usually most people just go 1, 2, 3, and 4 if you ever got up that high. So I'm saying that. Notice I used 2 hash marks to distinguish between BC and AC. Okay, so that we show that these are the same length and now these are the same length. Okay, and the third step, when we drew this segment right here, or this ray I meant, CD, this segment itself, CD, is equal to itself, isn't it? Obviously, any segment is going to be equal or congruent to itself. Well, when it's congruent to itself, that's called the reflexive property. Okay, now I didn't put 3 hash marks on here. I could have done that. Okay, I just didn't want to mess up the drawing so it was so confusing to you. But I would normally have 3 hash marks on there. I've already used 1, 2, and now 3. Okay, and so that third step here, you want to call it the third step, that's establishing that segment CD is congruent to itself. Okay, and that's what it says right here. Okay, so on the PARCC last year, one of these, it said, they gave you one of these steps. It said what was established in that step, and so these are the answers. If either these 2 segments are congruent, if it's this step, or these 2 segments are congruent, if it's this step, or segment CD is congruent to itself, if it's this step. So that will be on a quiz or a test. I'll put one of these 3 on here as well, so you need to know each one. Okay. All right, so that's angle bisector completed. 2 more. Okay, next one is construct a perpendicular bisector. So we remember from before when we talked about angles, when you watch that video and all that, perpendicular, and you should know this from middle school, perpendicular means 90 degrees, same as a right angle. Okay, the bisector, bi means two, and then sectors, two areas. So it splits into two areas, so it splits it in half. Bisector means to split in half. So we want to split this segment in half is what we're trying to do. And when we split in half, we also want it to be perpendicular. We want it to form a 90-degree angle when we do split it in half. Okay, so how do you do that? Step one, put the pointer on one end point and the pencil on the other. Okay, draw yourself a semicircle this time. Remember, equilateral triangle, we just drew like that top half, and that was it. Well, this time we're going to draw a full semicircle. Then we just turn it around. Step two, do the exact same thing, except for turn around, put the pointer on this side, your pencil on this end of the segment, draw your semicircle again. So notice now it's going to intersect in two places. And now we just connect those two segments, or those two intersections with our ruler. Take a ruler and draw that. Okay, I shrunk this down, so that's why it doesn't quite go right through this. When you shrink it down, it actually changes the proportions because it didn't shrink it down proportionally in all directions. So that's why it doesn't quite go through there, but it would normally go through if you used your compass correctly and all that. So don't think it's not going to. It will go right through those. And so that created a perpendicular. Remember, then we write a right angle symbol there, or the perpendicular symbol, same thing. It's the perpendicular part, and then bisect, remember, it means it splits in half. So we put hash marks here. This segment from here to here equals this segment from here to here. So one hash mark, one hash mark. So now this is a perpendicular bisector. 3 easy steps. Technical, the third step is just drawing the perpendicular bisector. Technically, construction-wise, you're only doing 2 steps. One semicircle, turn around, same way, another semicircle, and you're basically done right there. And you just have to connect it with your ruler now. But the compass part is done in 2 semicircles. Very simple. Okay? And you're going to practice this in class on your worksheet. Okay, you can practice it at home if you want. You can just draw yourself a segment any length and just do these steps. Okay, if you want to practice it ahead of time before doing it in class. All of these you can practice at home. So you come to class, boom, you're popping it out, no problem, and then you're helping those out who didn't do it at home. Okay? And you'll just be that much better prepared for a quiz and test. All right, our last one that I have down here, like I said, we may do one more, but this is the last main one that we're going to focus on here. Is construct a perpendicular, remember those 90 degrees, from a point not on the line. So we want to construct a perpendicular segment from through C. It's going to be perpendicular to segment AB. Okay? So we want this to come down here like this and be at 90 degrees. So how do we construct it? First step, put the pointer, I just call it C. Doesn't matter what you call it, I'm just calling it C. Put the pointer on the point, not on the line. Open your compass up so it goes past the line segment here. Okay, it's past it. It's not on this side. I don't stop it short because then it will never intersect when I do my arc. It's got to be past it. I could stop right there if I really wanted to, and then it would come right in here. If I went further down here, now if I go further down there, it's going to come out here like this, now here like this, which means now I need to extend my segment out, which is fine, to make sure that it intersects that segment twice. So however long the segment is, open it up a little bit more than past the segment itself, so you can make sure when you draw your arc, you can already have it go through and you don't twice, and you don't have to worry about extending the segment itself. Okay, but it's no big deal if you had to extend the segment, it'd still be right. Okay, so we established points A and B. Okay. Second, as we constructed. Second, put the pointer on A and the pencil on B. And then go ahead and draw an arc down here that goes more than halfway. Okay, so it's going to go past C, came down here. Then I turn it around and put the pointer on B and the pencil on A and draw my arc down here. So notice similar steps as what we've done with the perpendicular bisector. Okay, and so now I have another point of intersection D. I'm calling it D because I've already used A, B, and C. D. And now I just take my ruler and connect C and D together. That's my last step, and that will be at a 90 degrees. If you've done it right, it will be 90 degrees right there, and put the perpendicular symbol on it. Okay, that's simple. So you see, everyone is like 2, or in this case 3 steps. We did the arc first, step 1, then the pointer on A, pencil on B, draw 1 arc, turn it around, pointer on B, pencil on A, draw my arc. That gives me point D now, and now I just connect C and D together. Okay, and there's your perpendicular. So we created a perpendicular from a point off the line. All right, and that is it for our 4 constructions that we're going to focus on right now. Now, what you might, and you'll do on the worksheet, for example, if I draw a triangle for you, it might say do a perpendicular bisector of all 3 sides. So you do a perpendicular bisector 3 times, okay? And then it will intersect, those 3 lines or segments will intersect in the exact same point. And we'll get to those vocab words in that coming up as well in class. All right, that's the end of this lesson. Go ahead and practice these at home. You can make up your own segments and point off the line, all this kind of stuff. Practice at home. So when we come to class, you already completely do it, or if there's something you don't understand, you know exactly what to ask in class. So you're not starting from scratch. All right, and we'll see you in class. Have a good day.